Hey guys, today we're going to see the count of factors, like how we can do the factors in optimal way. Okay, but before going to do something, what we usually do, first of all, what is factors? First of all, what is factors? Okay, so factors is nothing but a number which divides a number completely. Okay, for assume like we are taking a number n, or any number n. So what are the factors of n? Then any number which divides n completely. Basically, n is some number, n modulus I. This is the number, okay, which divides completely. If n modulus I equal to 0, that means this I, which is a number, divides the number n completely, right? That's what we are saying. So these are the factors. So for example, basically, what are the factors for 10? So assume like n is equals to 110. Now 10 modulus 1 equal to 0. Is it true? 10 mod 1 equal to 0. Yes, 1 tens are 10, right? And now 10 mod 2, is it completely divisible? Yes, it is. It is completely divisible. Like 2 5s are 10. Barabar. Now 10 modulus 5 equal to 0. Is it completely divisible? 5 2s are 10. Yes, it is completely divisible. There are no reminders, right? Now 10 modulus 10, is it completely divisible? Yes, 10 ones are 10. Yes, there are no reminders, so it is completely divisible. So these are the factors. These are the factors 1 2 5 are 10, and these are the factors for n is equals to 10, right? What is the approach for this brute force approach? Brute force is nothing but like what are the first thinking, like to solve the counterfactors. So basically we need some variable called count, right, to count the factors. And what it will be like, now to iterate a number, because for n is equals to 10 we need to find the factors till 10, right? So what we'll do, we'll take a loop, we'll take some for loop. Okay, then what we will iterate till I is less than or equal to n, right? Barabar. Then what we'll do, we'll check if n modulus I equal to 0, right? Basically if it is equal to 0, which means completely divisible, then we will count plus plus, right? Then what we'll do, we'll simply return count. So that's how we can get easily, right? So this is what a basic approach will be. Now let's see in IDE. So whenever you're solving a problem, any kind of problem, try to do it in functions. That makes life very easier. Okay, because if I write in main function, like everything will be on in main, then I can't distinguish the problem, right? So if I have a very big problem, then I have to divide the problem into small parts such that I can easily understand, and whoever reads the code also, he will understand it better way, right? So now what I'm doing is, I will create a function, static int count of factors, where I'm not passing anything, I'm not taking any variable. Okay, I'm taking the variable input here only. So int n equal to obj dot next int of, yeah. Now what I said, like we have to take a count variable, count equal to 0. Then we need to take a for loop, right? I less than equal, is the I tell me something, is the I should be 0? We have to start from 0, because 0 doesn't have any factors, right? So we have to start from 1. Yeah. And now what I have to do, I have to check if n modulus I equal to 0. As we said in earlier, that any number which divides n is a factor. So that's what we are doing here. if n modulus I equal to 0, then what I have to do? I have to count plus plus, right? Now what I'm doing, I'm doing return count. Okay, so here I have to, whatever I'm here returning, I have to store it, or I have to print it, right? So simply I will print here. I will call the function here itself, count of factors, then I'll print over here only. Okay, now what we said for a variable n is equals to 10, what are the how many factors are there? There are 4 factors, right? So I need what I need in output should be 4. Let's see, is it right or not? Oh my god, cannot find symbol obj. Okay, sorry, then I have to replace this. Actually it's out of scope, right? Now I have to, yeah, and I have to pass the variable n here. Yeah, so these are the silly mistakes which you should not do in interview.
I am sorry, Babu.
Yes, we got 4. Got it? So this is how we are solving the count of factors. As you see here, what are we observing here? See, when n is 10, what I'm doing, how much time does it taking? Check first. So for this for loop, how much time does it taking to do iterations? How many number of iterations it is taking? It is taking n, right? It is taking n. Basically, if n is equals to 10, then 10 iterations are happening for this, right? Now for n is equals to something, for n is equals to 100, then what I'm doing? I'm doing 100 iterations for this for loop, right? Because we are checking from 1 to n value, I less than or equal to n. So basically we are doing 100 iterations. Now for example, some given number is like, for example, 10,000 something. 10,000. Now the loop, the whole program will do in 10,000 number of iterations, right? 10,000 number of times. So is it an optimal solution? Assume, like for example, if I'm using only one user, for example, I started a company and I have like users are using this kind of program, count of factors, multiple times. So every time they are doing 10,000 iterations. For example, n is equal to any value, 10 to the power 8 also, 10 to the power 6 also. They are doing 10 to the power 6 iterations if they are taking 10 to the power 6 input value, right? So is it a bearable cost for the company? For me, no. It's not an it just cost machine, electricity and everything, right? Internet and everything. So basically this is not an optimal solution. Now to come up with the optimal solution, you need to know these things before. See, now what I am going to say is, if for example I is there, n is there, right? So for 10, 2 is a factor, right? So if 2 is the factor of 10, then which number should I multiply to get 10? I have to multiply with 5, right? So basically I can write here in general way is I into j equal to n, right? Can I write like I into j equal to n? Yes. So for any I and j, these both are factors of n. Take anything. For example, if you are taking 24, n is equals to 24. Now can I say that 3 and 8 is the factor of 24? These both are factor of 24. If I and j is equal to n, then j is equal to n by I basically, right? So here I and n by I are both factors of n. are factors of n. Can I say it like that? Yes. Can I say it like that? I and n by I are both factors of n. Let's understand it in a better way. Okay. Let's understand it in a better way. Now, for example, as we said, what I'm stating that I and n by I are factors of n, right? Now we'll do one thing. We'll take I, okay, and we'll take n by I, okay. Now let's do one thing. Taking anything, sure. Now, what are the factors of 24? Basically, 1 is a 24, right? What the n by I will be? So basically, n by I is nothing but 24 by 1, right? So it will be 24 only, n by I the value, and 2 is a factor. What the n by I will be? 24 by 2, it will be 12, barabar. And what is the if I value is 3, the factor is 3, then what will be n by I? It will be 8. Now if factor is 4, what will the n by I value? It will be 6. 4 6 are 24, right? Now we take some different, okay, color. Now for 6, what the n by I will be? 4. Now for 8, what the n by I will be? 3. 24 by 8, 3. 3 8s are 24, right? For 12, what the n by I will be? N is nothing but here 24, right? 24. So 24 by 12, it will be 2. Now what 24 by I will be? Tell me. 24 by 24, it's 1. So can you observe something up to here? Can you observe something here? Basically, we are repeating this whole thing here, right? And we are repeating this whole thing here, right? So from this logic, what we can say is we can reduce the time complexity. Can we reduce the time complexity from here? Yes, we can, because we are doing the half of the iteration, right? If I know that 1 is a factor, then I can easily know that n by I is also a factor, right? If I know that 2 is a factor, then I can know that 12 by I, which is nothing but 24 by 2 is 12, is also a factor. If I know the 3, then I can know the other factor also, which is nothing but n by I, which is nothing but 24 by 3, which is 8, right? If I know the I is equals to 4 is a factor of n, then can I say that 6 is also a factor of n? When we are writing a loop, what we are saying? We are saying like I less than or equal to n. So we are doing for every number till I. So now we have the question, right? Like how much?
अबे जल्दी बोल, कल सुबह पनवेल निकलना है.
The loop should end. Where the loop should end to get order, to get half done only, right? So how much? What is the condition that need to be checked in for loop? So basically, can you see here something where I is less than or equal to n by I? Here you can see that I is less than or equal to n by I. Here 2 is less than or equal to 12, 3 is less than or equal to 8, 4 is less than or equal to 6. And when comes to this half, it is duplicate values are repeating, right? So basically here this condition is not satisfying. So 6 is not less than or equal to 4, right? So what we can say from here perspective is that I is less than or equal to n by I, right? This will be the condition in for loop, which I am going to write. But can we write it like this also? I into I is less than or equal to n. Yes, basically it means I is less than or equal to root n. Got it? Basically, but we prefer root n over I square. We will write this in for loop. The condition over here is right for every value. The factors are here. the condition is also right. Like, what are the factors for I 24? 1, 2, 3, 4, 6, 8, 12, 24, right? But when we are doing like this, still we are getting the factors, right? 1, 2, 3, 4, 6, 8, 12, 24, 1, 2, 3, 4, 6, 8, 12, 24, right? So basically this approach is right. Now how we can do in programming? Let's check it out. Okay, I will do one thing. I will comment this thing for future understanding, right? So what this value will be, the time complexity will be here is order of n. Yeah, this is time complexity for this will be order of n. Now we are doing this optimally. Okay, we are writing for this optimal solution. Optimal solution. Let's do this. How we can do? Now take int I equal to 0. I equal to 0? No, I equal to 1. I less than, it should be I less than or I into I less than or equal to n, right? Then I plus plus. Yes. Now what I have to do? I have to check that if n modulus I equal to 0, then this is a factor, right? I have to check for a number. As I know that if you're going here, can we say that if I count I, then I can count this thing also? Basically I'm counting, right? If I'm counting, first what I'm doing, I'm doing just count plus plus. Now what I will do is I will do count plus 2, because if I find that I is a factor, then n by is also a factor, then I can say that count is equal to count plus 2. Then I can simply count equal to count plus 2. Got it? Then I'm returning the count. Let's check it. Is it the right solution we are getting for 10? Are we getting 4 or not? Yes, we are getting 4. Now for 24, as we have checked here, for 24, how many factors are there? Here 1, 2, 3, 4, 5, 6, 7, 8. 8, right? So are we getting 8 or not? Let's check it. Yes, we are getting 8. But is it a correct solution? For some cases, for some cases like for 24, it is a right solution. But for some cases, it is not a right solution. Can you observe something here? What can you observe something here? Okay, I will tell you here. Okay, I will give you an example and we'll discuss on it. Okay, why I am saying like this? Okay, yeah. So let's do this. Yeah, for like same, I take I, then taking n by I. Yes, we say that it should be less than or equal to, right? Now what are the factors of 100? 1 is a factor. Then what the n by I will be? It will be 100, right? Now when 2 is a factor of 100, now what we can say, 50 is also a factor of 100, because 100 by 2 is 50. Now 4 is a factor of 100, right? Now what we can say, 25 is also a factor of 100. 100 by 4 is 25, right? Now what we can say, 5 is factor of 100. Then here 20 is also a factor of 100, right? 100 by 5 is nothing but 20. 520 is a 100. Now when it comes to 10 is also the factor of 100. So 100 by 10, what it will be? It will be 10, right? If you observe something here, you should get it. We said that it should be less than or equal to, 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 it should be less than or equal to. Yes, it is satisfying the things, right? But when we go deeper here, when we say like when I is equals to 20 is also a factor, right? Then what it will be? It will be the 5. But is it the condition is satisfying here, which is 20 less than or equal to 10? No, it is not. 20 less than or equal to 5? No, it is not satisfying. So basically this is we will take this out. Look over here. Here's what are the how many factors are there? Count the factors for here. 1, 2, 3, 4, 5, 6, 7, 8, 9 factors, right? So it should be here when we are counting. It should be 9 also, right? For this case, we got right. For this case, we said that the factors will be here 8. We are exactly getting here 8, right? But for this case, are we getting the right answer? What are the count of factors? Are we getting the right answer? Here, how many factors are there? 9, right? So we should check here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 10. There is one extra element. Then my count will be here 10, right? Is it a right solution? Is it a correct solution? No, it is not a right solution. Then what I have to do? I have to check for this condition, right? If I equal to n by I, then I have to count only one time. If I is not equal to n by I, then what I have to do? I just count 2 times. When it's coming to when I, for example, if I is equal to n by I, then what I'm saying is just count only one time. Else count 2 times, right? Then what we can get? We get the right answer, right? Can we get the right answer? Yes, we can get the right answer. So for I've not changed the code anything here. I'm just typing 100 for the previous code. Now what I'm getting here is I'm getting here 10, but actually the correct answer is here 9, right? When we are looking, the correct answer is 9, but we are getting 10. So as I told you, what I have to do is I have to just simply check the condition. If I equal to n by I equal to n by I, then you should count only one time. Else you count 2 times. Okay, this condition is right. Now what I have to get for when I'm getting input 100, then what the output should be? It should be 9. Let's check, is it right answer or not? Boom. Now what is the time complexity here? Can I say that the time complexity is nothing but is I square less than or equal to n, right? Can I optimize it? I is less than or equal to root n. So basically my condition is satisfying up to root n only, right? For example, n is equals to 10. And what is the root of 10? Something like 3 point something. Yeah, something like 3 point something, right? So so for this, in general way, what we did in the first condition here, if we do n is equals to, if we are taking n is equals to 10, then we are getting here, we are doing the, what is the time complexity here, is the order of n. Basically we have to check every condition, right? So for this, can we say that it is the time complexity here is only order of root n, right? Can we say from this thing, can we say from this condition that we are looping up to only order of root n only, right? So basically for the first loop, what we did 10 iterations for n is equals to 10, but for this code we are doing only it for 3 times. Understood? We are doing this only for 3 times. Got it? So basically this is the thing, this is the optimal solution. This time complexity is order of root 10. Okay, this is the count of factors. Thank you so much for watching. Goodbye.